All right, so now that we have some knowledge about what quadratic equations are and a little bit of information about how we might be able to solve a quadratic equation if it's fully factored and set equal to 0, we're going to get some practice. Okay, so before we launch into some examples, this is just sort of a step-by-step what you want to be thinking about when we go to solve a quadratic equation. So first of all, simplify the equation by using distribution and combining like terms if necessary, if you've got parentheses or whatever you've got going on, and then move all the terms onto one side of the equation so that the other side is 0. And so it should look like the standard form, the ax squared plus bx plus c equals 0. And from there, factor the expression, the quadratic expression. The ax squared plus bx plus c, okay? And then apply the zero product principle by setting each factor equal to 0, and then you want to solve each of those equations. And once you do that, it's always a good idea to check your solutions. Make sure that they work. It's a great way to check your work. Okay, so let's get a little practice doing this. So here are a couple of examples, and our directions are to find the solution or solutions to the following quadratic equations, check your solution or solutions, and state the solution set. Okay, so we will learn when solving these quadratic equations, we might have up to 2 solutions. We might have just one solution. It's a possibility to have no solutions, no real solutions as well. But if it's factorable, and we're concentrating on that, if the quadratic equation is a factorable thing, we should be able to solve it. Okay, so in this first example, x squared minus 8x plus 15 equals 0. So before we can use the zero product principle, we need to factor x squared minus 8x plus 15. Okay, so I'm already thinking over here on the side, I know I'm going to have factors of 15 that add to negative 8. So right off the bat, I'm thinking, well, if I've got positive 15 as a product and a negative value as a sum, then both of my numbers have to be negative. And with 15, I'm thinking negative 3 and negative 5, right? Negative 3 times negative 5 is positive 15, but negative 3 minus 5 is negative 8. Okay, so when I factor this, I'm going to have x minus 3 quantity times x minus 5 equal to 0, right? Okay, so because I have this in factored form now, it's a product and I've set it equal to 0, which means that either x minus 3 equals 0 or x minus 5 equals 0. Okay, solve both of those. Okay. Over here with x minus 3, I'm adding 3 to both sides, so I'm going to have x is equal to 3. And over here with x minus 5 equals 0, I have to add 5 to both sides. So I'm going to be left with x is equal to 5. Okay, now check these in the original equation all the way back up into the x squared minus 8x plus 15. That's what you want to do. Always go with what you're originally given. If x equals 3 is a solution, we should be able to plug 3 into the original equation. So we'll have 3 squared minus 8 times 3 plus 15. Is that equal to 0? That's our question, right? So I have 9 minus 24 plus 15. Is that equal to 0? Negative 9 minus 24 is negative 15 plus 15. Is that 0? Yes, it is. Very good. Okay. And what about 5? Is that a solution? So I'd have 5 squared minus 8 times 5 plus 15 equals 0. Is that equal? Okay, so 25 minus 40 plus 15. 25 minus 40 is negative 15 plus 15 is equal to 0. Okay, so is this a true statement? It is. All right, so the solution set includes 3 and also 5. Okay, so with this next example, we've got negative 3x squared minus 3x plus 18 equal to 0. Okay, so again, it's in standard form. It's already set equal to 0 for us. I notice that the leading coefficient is not 1, but it's not a perfect square, nor is the last term not a perfect square. I also notice that we've got -3 and -3 and +18, and 3 will divide 18. So with a negative out front, I'm going to go ahead and just factor out a -3. So I have -3 times the quantity x squared plus x minus 6, right? So let's see, -3, if think about that, distributing that back through. So we'd get -3x squared, -3 times x is -3x, -3 times -6 is +18, right? Okay, so now I'm looking at that trinomial after taking out the GCF, the x squared plus x minus 6. I can factor that. Factors of -6 that add to 1. Well, if you've got to have two numbers that multiply to give you -6, one of them's got to be negative. So I'm thinking -2 and +3, right? -2 times 3 is -6. -2 plus 3 is +1. So I would have x minus 2 times the quantity x plus 3. Okay, so now if we're using the zero product principle here, people always ask, well, if you have a GCF like -3, how do you account for that? Well, -3, that -3 that we pulled out, it is a factor of the equation here, but -3 can't be 0, right? So the only thing that you have to worry about that could be 0 would be x minus 2, right? So x minus 2 equals 0, or maybe x plus 3 equals 0. Right? Okay. So x minus 2 plus 2 equals 0 plus 2, right? Add 2 to both sides, and we get x is equal to +2. Over here with x plus 3 equals 0, we would subtract 3 from both sides and be left with x is equal to -3. All right, so let's check it before we declare that we've done this correctly. Make sure that we plug things back in. So into the original equation, I'm going to put 2 in, x equal 2. So -3 times 2 squared minus 3 times 2 plus 18 equals 0. So -3 times 4, right, 2 squared is 4. That would be -12. -3 times 2 is -6 plus 18. -12 minus 6 is -18. Oops, forgot the equal 0 there. There we go. -18 plus 18 is also 0. Yay! Okay, so that one works. So we know that x equal 2 works. How about x equal -3? So if I plug -3 in for x, make sure you square all of -3 there with the x squared. So -3 times -3 squared minus 3 times -3 plus 18. Is that equal to 0? Well, -3 squared is 9. 9 times -3 is -27. -3 times -3 is +9. Plus 18 equals 0. -27 plus 9 is equal to -18. And we're adding 18 to that. Does that equal 0? Yes, it does. So the solution set is -3 or 2. Okay. By the way, I always like to write the numbers in numerical order when I list them in a set, but you don't have to. So this gives us some good practice, and we're going to continue to get practice with it.